Good morning, everyone. Thank you so much for joining our webinar today. My name is David Kalmbach, Head of Technical Solutions and Support at FRAMOS, and I'm thrilled to be your host for this session. At FRAMOS, we are dedicated to making latest imaging technology easily understandable and accessible. With that, we are supporting our clients to excel in building innovative imaging solutions of tomorrow. For today, I'm excited to have our long-standing partner SONY joining us to share insights on the use of SONY sensors for sports analytics. I'd like to welcome you joining us for a walk through core challenges within the sports analytics market from SONY perspective. Furthermore, we are going to learn about key factors to consider during selection of optimal sensor solution for optimized outcomes in sports analytics. Let me introduce you to our speakers for today. Alex, Business Development Manager at SONY Semicon EU, Giuseppe, Technical Imaging Expert at FRAMOS, and Axel, Managing Director at RESTAR FRAMOS. I'm looking forward to all of them providing their expert perspective in today's discussion. Here's a quick look at our agenda for the webinar. Right after my short introduction session, I'll hand the mic over to Axel, who is going to introduce RESTAR FRAMOS to you and explain how the company is connected to the SONY FRAMOS collaboration. Axel will then hand the mic over to Alex, who will speak for about 15 minutes about challenges and sensor solutions for sports analytics applications. Giuseppe is going to follow up, explaining how RESTAR FRAMOS and FRAMOS together support getting optimal information out of the camera front end, hence achieving best analytics results. After about 25 minutes in, we'll wrap things up with a 5-minute Q&A session where we'll address your questions and provide additional insights. Before we dive in, I'd like to highlight the question feature in this webinar platform. Please use this icon to raise questions during the webinar. Questions will be tackled during the Q&A session. For any unanswered ones, we'll come back to you soon after the webinar. Now, without further ado, let me hand it over to Axel from RESTAR FRAMOS to kick things off.
Hello, good morning. My name is Axel Kreppel. I'm the Managing Director of RESTAR FRAMOS Technologies here in Munich. You may be wondering why there are two FRAMOS companies here. The reason is as follows. On October 1st of this year, FRAMOS transferred the distribution of SONY image sensors to its former subsidiary, FRAMOS Technologies. Prior to this, FRAMOS Technologies was already a joint venture between FRAMOS in Munich and RESTAR in Japan, focusing on the distribution and sale of general semiconductors. With this shift, FRAMOS has now been renamed RESTAR FRAMOS Technologies and also has taken over the right employees from FRAMOS who were previously responsible for SONY distribution. So from now on, FRAMOS will concentrate on the development and production of image sensor modules, what you see here on the lower side there, while RESTAR FRAMOS will focus on the support and sale of SONY image sensors and other semiconductors. Here you see that our partner in Japan with about $3.9 billion revenue there, and the FRAMOS here in Europe in the end. And this is how we are now positioned and how we are now set up here in Europe as RESTAR FRAMOS Technologies. This is an overview of the RESTAR group. They are based in Tokyo, as I said before. We are down here on the left-hand side on the device business unit. The device business unit of RESTAR is the biggest one with about $3.3 billion revenue. They are a major SONY distributor as well in Japan with about $1 billion revenues just only for the SONY products. Here you see how is our worldwide setup there. The headquarters of RESTAR is for sure in Japan, in Tokyo there. We are running a warehouse here in Munich and our European headquarters there. We are having a joint warehouse with FRAMOS in Čakovec, Croatia there as well. And we also have a subsidiary in Canada and in the US. So we are covering, let's say, all of the Western world. What is in for you, or what are the benefits? Yeah, with this big company there in Japan and more than 30-40 years of expertise in the SONY products there, this is a very, very close partnership to SONY, and they know SONY very, very well. They have a deep technical expertise, and they also are exchanging sometimes engineers, which are coming from Sony, then working for RESTAR, especially on the vision and imaging side. RESTAR is also running an own R&D lab, and having also other vision-related applications like AI or something like that. The good thing for the availability of Sony sensors is a Sony image sensor stock with more than $30 million, what they are maintaining there. So in case there is a shortage or there's an urgent demand of samples or whatever else, we for sure can ask them whether they can help us or something like that. And the other thing is, if you are not sure whether you want to use the pure image sensor there, you also can use the FRAMOS image sensor modules, which is an easy integration then into your system. So that makes it possible for you that you have a faster development and R&D time, and also a faster time to market. This is an overview of the Sony products. The image sensors, what they have there. They have rolling shutter, they have global shutter sensors, they have Swire technology, time of flight, their stabilizers, EVS sensors, multispectral sensors there. And also we support the SLVS-EC, whether it's the older SLVS-EC, but also the high-speed SLVS-EC 3.1. So there is an IP available from us as well, what you also can license to make the development easier. When you want to reach out to us, you can use our telephone number, you can use our website, you can use our email address there. So please feel free to reach out to us in case of questions dedicated to the image sensors or other products, what you might see on our website. Thank you.
Okay. Thank you, Axel, for the introduction to RESTAR FRAMOS. And then let me hand it over to Alex from Sony.
Thank you, David. So also warm welcome from my side. Good morning, everyone, and thanks for joining. Let me briefly introduce myself. My name is Alexander Papst. I'm Business Development Manager at Sony Semiconductor Europe, and today I'll talk about how Sony image sensors could address challenges in sports analytics for indoor and outdoor venues. So over the approximately next 10-12 minutes, I will walk through some, let's say, specific visual sensing challenges that sports analytics systems might face in demanding environments, and how Sony sensors can or could address those challenges. And we will explore basically three different kind of product lines or technologies: our AV sensors, our StarWest sensors, and our new IMIX06A high resolution sensor. So let's begin. So sports analytics is transforming how we understand player performance, team strategies, game dynamics, and really we are talking about the ability to track player movement on the pitch, ball trajectory, and also tactical patterns with precision, and enable, let's say, data-driven decision making on the field rather than sports. So, but sports venues obviously present demanding conditions for visual sensing systems, and I came up with three challenges which seem the most demanding. And let's start with the first one, which is low light sensitivity requirements. So sports venues typically have challenging lighting conditions, and cameras must continuously capture the entire playing area under various or varying conditions. So we need clean images without excessive noise, and the image noise directly impacts the reliability of the tracking data. So tracking algorithms really need to be able to clearly distinguish between different objects and players. Secondly, there's the dynamic range challenge. So cameras usually face a dilemma. So you could either expose for bright areas and you lose detail in the shadows, or you expose for the dark areas and your highlights will blow out. So, and we must avoid both here. So consistent data capture across the entire playing areas is essential. And if the tracking system loses players when they move from bright area to dark areas, that analytics or your analytics might become unreliable. And lastly, of course, the system requirements. So obviously not all, but most sports analytics systems would need, let's say, a fixed camera system with wide angle coverage of course, continuous recording without freeze frames, and appropriate resolution plus frame rates for tracking fast movements. And of course, in the end, they must be also cost effective, also with multi-camera deployments. So in the end, the core question is, how do you balance all of those factors? And image sensors here are an essential part, and which are key enablers. So Sony offers here a variety of solutions and technologies, and I would like to give you some examples here. So let's start with the first one. So this is our let's start with our StarWest technology. So these sensors are really incorporate features that that are quite useful for sports analytics, I think. And first of all, there's the low light performance of those sensors. So as I mentioned, this is really important for sports venues, and many arenas usually don't have like the optimal lighting conditions. So that means Sony StarWest sensors are really designed for low light performance, capturing like detailed images even in dark conditions. And StarWest 2, so the next generation here, improves on this with a wider dynamic range and better image quality, delivering, let's say, clearer results in both visible and also in NIR field or lighting. Let me give some, let's say, let me give you some concrete numbers. So we measure this low light performance using a KPI called SNR1. So this shows the luminance needed to get pictures with a signal to noise ratio of 1. So a smaller number of SNR1 means better low light performance, or better performance in low light conditions. So just as a brief example, so our IMX678, for example, delivers a SNR1 of 0.29 lux, and our 585 is even below that, so at 0.117 lux. And also both sensors offer a quantum efficiency at 850 nanometers, of 51% at 850 nanometers, which means really enhanced near infrared performance. So what this means for sports analytics, really clean images, really in poorly lit venues as well, and reliable analytics data. So let's talk about another challenge here. In sports venues, you have really bright spotlights illuminating the playing surface while simultaneously dealing with dark areas, let's say around the court or the field perimeter. So that's a dynamic range challenge, basically. Some sensors would either blow out in the highlights or lose details in the shadows here. And for example, our StarWest 2 technology delivers a wide range of more than 80 dB improvement compared to our StarWest 1 generation for the same pixel size in single exposure. There's also flexible HDR options available. So there's clear HDR or dull HDR, which means digital overlap HDR, with different frame rates and bits. And also single exposure dynamic range could go from 78 to 88 dB, depending really on the sensor. So this results in really consistent, or can result really in consistent tracking across the playing area, and yeah, no details will be lost in the shadows or the highlights. So now let's move to the next category here, to our AV sensors. So and I would like to walk you through why those sensors could be also quite suitable for sports analytics. First, really they're engineered for continuous video applications and to maintain consistent performance during also extended recording sessions. And secondly, they also offer a balance between resolution, frame rate, and sensitivity, really for, in the end, reliable tracking. And third, the cost-efficient scalability. So for multi-camera use cases where you have several deployments covering large venues, this is also relevant in the end for, of course, managing the system costs. So there are two examples I brought today. There's the IMX577 and the IMX477, both offering HDR or dull HDR option with also quite attractive frame rates at a 4K resolution. Just as a brief example, what's available in our portfolio here. Okay, and then lastly, I would like to focus on a new product, or a relatively new product here, which is called IMX06A, our new 50 megapixel high resolution sensor. And I would like to introduce this sensor and why this also might be very interesting for sports analytics. So as I mentioned, we have a 50 megapixel sensor. This is really the highest resolution available in a 1-inch format sensor. And why I think this, or we think this does matter for sports analytics. Really, with 50 megapixel, you can capture larger playing areas from single camera positions. And this really means you can reduce the total number of cameras needed to cover a venue. Fewer cameras also mean reduced system costs. It also means simple installation, less cabling, reduced network bandwidth requirements, and in the end also easier maintenance. And really that for larger venues, this also can impact your total cost of ownership. But of course, from performance perspective, the IMX06A also offers flexible performance modes optimized for different scenarios. So you would, for example, get 25 frames per second at the full resolution or maximum detail capture, or you also could switch to a 50 frames per second in binning mode. So there's a special quad buyer coding on the image itself, which enables you to have a 2x2 binning with increased sensitivity, ×4 sensitivity to really boost in low light conditions. So if lighting conditions become quite challenging, you can switch modes and maintain image quality. The IMX06A also addresses those dynamic range challenges, which we have discussed earlier. With this kind of improved specifications. So here you would get a 96 dB range, dynamic range with dual conversion gain HDR and also quad buyer coding HDR. So there are 2 HDR modes available on the sensor. And really this handles venue, or this can handle really challenging venue lighting contrasts. So in combination with the quad buyer coding with the 2x2 binning and the dual conversion gain HDR, this really delivers good performance in the end. The high resolution also enables precise tracking and detailed biomechanics analytics if needed. So if you can track also subtle movements, analyze player form, and capture details that lower resolution sensors would miss. And it includes also a software trigger capability for multi-camera synchronization. So when you're running a multi-camera system, frame synchronization is of course relevant and for accurate 3D tracking and analysis. Okay, now let me summarize what I just said here and our, let's say, not complete, but our suggested portfolio for sports analytics, as shown in this table here. So I don't want to go through all the details, but we have firstly our AV sensors, or proven AV solutions, which providing cost-effective, reliable options also for multi-camera deployments. Then we have our Starvis security sensor solutions, but also suitable for sport tracking or sports analytics, we think, which are really enabling challenging lighting conditions. And then lastly, our new sensor, which is IMX06A, where we really have a good new sensor in the pipeline for addressing several challenges and improving imaging characteristics for sports analytics. So I'm quite confident that we would have a solution for any kind of application you can think of. And in that sense, I would like to thank you for your attention, and I will now hand over to my colleagues from FRAMOS, who will show you some practical implementation examples and how they can support system design.
Thank you, Alex. Good morning, everyone. Yes, please go next and look how we can optimize the sensors that are already amazing, but we know from the system perspective that there are end application and requirements that are at higher level. Here is an example. Typical application in sports is a jersey number to track the players on a soccer field. And the customer says, okay, I need 10 pixels to detect my jersey number, and this is the requirement from AI. So how I can get this? And this is quite far from image sensor, but is anyway very closely related. So what we can do from system perspective is also to imagine, to do some simulation and figure out how the combination between the sensor and the lens can give you the real image. And from there, you can choose if you use one sensor, two sensor, very wide field of view, or fisheye lenses. And so this is a way how we can support customers implementing the systems in the sports application. But not only, because we are talking about the lenses, we can look and we can look at a topic that is the aperture. We say low noise or low light, how these are related and how this can be anyway solved or better managed. I have here on the left a signal to noise ratio plot, a diagram. I don't want to explain and hit very deep here, but I want to highlight that low light condition in sports might come not because there is low light in the environment, but because the sensor must run very fast. And when you see in the plot that reducing the exposure, so to get speed, you get less light. And because you get less light, then you run in low light condition from the sensor perspective. And this is very important. That's why sensitivity, SNR1, as Alex explained, it is very important because we can quickly run into the left side of this plot. But of course, from system perspective, we can also look, and we must look at the lens, because on the right, you see different f-stop numbers. What that means, from light perspective, means that just one stop of differences, you double the amount of light that is coming into the sensor. So the nice is that you have maybe 50% of the exposure time, so 50% of light less, but because you use a higher lens, then you have 2 times again, and so you in some way balance the amount of light. Of course, different f-stop numbers means different depth of field, some aberration or some loss in the resolution. And so this is why build a camera, an imaging systems for sports, and it could be challenges. And here is what we can support in FRAMOS. Another point is ISP. A very common question I receive from customers are, I need the green should be brilliant, very brilliant green, because I want to impress the watchers when they look at the soccer game. And this is related to the tuning. So remove the noise because we run in low light condition, and also increase the brightness of some colors, maybe even a bit far away from the standard coding, because we want to highlight some features in the application. And the green is one of the typical. So this is another point that is needed to get the best in the systems in sports. So Alex mentioned about the new sensor, and indeed, even in my picture before, in the field of view, the fisheye, it was maybe not that much, and the reason is because there you only have 12 megapixel. IMX06A comes with 50 megapixels, so in this case, the ratio and the number of pixels that you have per small angle is much higher. And that's why we believe this is a very nice sensor for a sport application where we need very wide field of view. We are almost there, and Axel also mentioned that we can provide a validated stack, or what we call FRAMOS sensor module, or FSM, and this could be another very nice product to start using and doing implementation in our sports systems. That's all from my side. I then have give the stage to Axel again. So Axel, please. Axel. So.
So when it comes to support, and you see to select the right sensor, to think about your application, the question is always who can help you there. Yeah, as we are having quite a long history in Sony partnership there, technology partnership there. Our imaging experts, which are dedicated to Sony image sensors, are listed here. This is Flavien Hiroguin and Eben Johnson. They are here in Europe for answering your questions, helping you in case there are technical problems, issues, whatever else. Yeah. So please feel free to contact us or to contact them on the support@restarframos.com. And you will receive some immediate help and call or conference call or whatever else what is needed then. Okay, then I hand over maybe to David back, and we will go to the FAQ session.
Thanks a lot to all the speakers. As Axel mentioned, we're happy to now take on all the questions. There's already plenty asked. Feel free also to ask further ones. We've got about 5 minutes to dive into. Let's get started with a question towards probably Sony and Alex. Can you explain in practical terms what the SNR1S values mean for sports venue operators? For example, how does the IMX585's 0.17 lux compare to the typical indoor arena lighting conditions?
Sure. Yeah. Thanks, David. So as I mentioned already briefly, the SNR1 tells you the minimum light level where the sensor can still produce a usable image. So the IMX 585 0.17 lux, for example, means it performs excellently even in very dim conditions. So with that said, the IMX 585 has kind of tremendous headroom, ensuring, let's say, clean, noise-free images in the dark, also dark corners of the venue. And I guess this is critical for consistent tracking data across the entire playing area. I guess, yeah.
Okay.
I think that should answer the question.
Thanks a lot, Alex, for the question, for the answer. Then another question is about the shutter technology for these sensors. The audience recognized that there were mainly rolling shutter sensors shown in today's presentation, while the native assumption could be that for sports where everything is fast, you would actually require global shutter sensors for perfect outcomes. So first question, and I can confirm this, all the sensors that have been shown today, including the IMX 06A, are indeed rolling shutter sensors. And then maybe a question towards Sony and Alex. Where would you make kind of the differentiation when a rolling shutter or global shutter sensor would be better suited for the sports use case?
Yes, I think first of all, David, I guess you're correct. So all the sensors are rolling shutter here. So I think it's always like a trade-off you're having, right? Of course, on the one side, cost and imaging characteristics, of course, depending on whether you would need a very high dynamic range images. So rolling shutter pixel, of course, always is more sensitive to low light, always offers more dynamic range. But on the other hand, also is a cheaper pixel in the end, right? Which means also the sensors usually are cheaper than a global shutter sensor, right? Because the pixel architecture is different. Of course, if you want to really need global shutter for really, really high speed applications, that's something you would need to consider to avoid, let's say, blur images or so. But in the end, I guess it's also something you need to evaluate, especially when you're looking at high resolution sensors. High resolution global shutter sensors are usually very, let's say, expensive compared to rolling shutter high resolution sensors, right? So I think that's also some you need to basically decide whether what kind of application you are targeting, right? And if you can work with a rolling shutter sensor, I think it would make sense to work with a rolling shutter sensor.
Okay, thanks a lot for that answer, Alex. I believe that's fair enough. Then next question would go in the direction of IMX 06A, and there's a question around the binning. So the IMX 06A provides binning, and the question is, in which domain is the binning actually done? Is it in charge domain, analog domain, or digital domain? Would you be able to answer that one right away?
Good question. To be honest, I'm not quite sure on this one.
Maybe Giuseppe, can you support on that one?
I also need to confirm, but I think it's in the analog domain. So is because the pixel is a quad Bayer, and in RGB this is sometimes a challenge because the binnet pixel must be closer, and this is the case of IMX 06A. So, but yeah, I need to confirm. Yes.
Okay, so we'll come back to you on that question. Then we'll take one or two more questions on. There's more in the chat. We're going to come back to you on these as mentioned later on. So one question is related to processing platforms. First of all, which processing platforms actually do you see are typically used in such sports analytics applications? And then the other one related to it would be about clear HDR of the IMX678. If you know if there's any plan for these processing units, whether or not to support this HDR function of the 678. Maybe Giuseppe, can you speak to that?
Yes, indeed. So again, the cost is a part of the game, and we see an XP low hand, IMX8, for example, NVIDIA a different range, Jetson, Orin, and also in some cases the Nano. Some customers are using the Qualcomm platforms, and so these are the most common that we see. Clear HDR is indeed challenging. NXP is supporting that. NVIDIA is not on the Qualcomm. That should be supported as well. I'm not aware that there is a plan to support clear HDR on NVIDIA, but this should be asked to NVIDIA itself. Yeah.
Okay, thanks a lot. Then let's take a last question on, which is about the comparison between the audio-video solutions 477 and 577 that you've shown, Alex, and the Starvis 2 security solutions like 678, 675, 585. How should customers decide which one is the right for their specific sports or venue type? How to decide between the AV lineup and the Starvis 2 lineup?
I think you need to do a differentiation here, right? So of course, the Starvis sensors are the original idea for designing them was really to use them in security cameras. So that means, of course, the pixel design is special. They offer, let's say, good near-infrared lighting, which is important, right? And also the low light capability of those sensor technologies is very, very good, right? Of course, they're a little, let's say, higher end compared to the AV sensors. So it depends whether you can work with the AV sensors or if you need better performance in low light, for example, or in HDR, then of course you can think about taking a Starvis sensor or a Starvis 2 sensor.
Okay, thanks a lot. So with that, let me conclude the Q&A session. Let me remind everyone that for the open ones where we did not yet come back to you, we are going to do so shortly after the webinar. Let me thank you at this time for the attention. Let me also thank again all the speakers for their great contribution and talks. Keep in mind our upcoming webinars in the winter timeframe, December 4th. We are going to learn about Sony global shutter and rolling shutter large format sensors overview with Sony. And on December 11th, it's a more generic topic about what is actually good image quality. So please, if you would like to contact FRAMOS, scan the QR code, fill out the contact form at the homepage, and stay subscribed to the newsletter for any updates on newsletters and the like. Thank you very much again. And with that, I'm concluding the webinar for today. Have a good day, everyone. Bye-bye.